Okay. So basically, what is going to be how it works is with the so far we talked about the different ways of writing the SQL query and different ways of creating the tables and what are the different constraints that you have and how to add the data and what is your TCL transaction control language, how it works. So all those things have been discussed in the last couple of classes. So in the last class about the SQL, we talk about what are the different other database objects that you have in database. So far, we talked about what is a table and how the data is stored in the table and how the data is, how the data is stored, and all these things have been discussed. But we never really talked about what are the other database objects. In database, you also have different other database objects, so which you call them as views, and you talk about the indexes, let's say the sequences, views, indexes, sequences, and you also we'll also talk about the materialized views. So how do you use materialized views here, and indexes, sequences, and the next one is about the synonyms. So basically, how do you use the synonyms and then access. And we'll also talk about in the today's class what do you mean by the partition, and also what do you mean by the DB link, database link to work. So these are all the different other database objects. In the next coming classes, we'll talk about what is PLSQL, and in the PLSQL, we'll talk about what is a procedure, how to define a procedure, what is a function and how to define a function, and what are the different packages or objects that you can create. So these are all the things that you learn in the PLSQL. It is not an SQL object that you're going to create. So we'll talk about all of them from the next class onwards. Okay. So when you take a look at the other type of database objects, what do you mean by a view? So view is like you can call that as a container to view the data from the database table. So view is something that which physically will not exist in the database. It will not exist in your database. So when you look at the view, physically it will not be there. Or you can define a view as a predefined query stored in the database. Predefined query stored in the database. So what is the use of views? So basically to hide the data from different users, we use views to hide the data from different users. To hide the data. And the second use is that it makes the complex queries easier. It makes the complex queries easy to retrieve the data. So these are all the uses of the views. So view is nothing but the predefined query stored in the database. So let me show you. I have a employee table. Okay. So this is an employee table which is actually physically existing in my database. So if I have to retrieve the data on top of it, it's just like a container which helps you to retrieve the data. Is view is physically stored separately just like your table? No. View is not something that which stores the data separately like your table. So this is a view which is like a container to container to retrieve the data from your database table. So basically the views are created into two types. One is the simple view and another is called as a complex view. Simple view, and the next one is called as a complex view. So when you talk about a simple view, let's say a simple view, if it is retrieving the data from only from one table, and if it does not contain any function, if it does not contain any function, and if there is no group by clause, then we call it as a simple view. So let me create a one, then we'll come back to this definition and then see. So how do you create a view? So it's basically, if I have to create a simple view which will read the data for me, so I can go here, check, do I have any views? Okay, there are already some views which are present in this SQL. So let me just try to create another view. Okay, so how do you do that? And you have to tell me whether it is a complex view or a simple view. I'm creating, this is a syntax that we follow, create view, and then provide the name. Name is basically, let's say, employee underscore Jan 2015. See, in an organization, if you think about the use of views, is that, let's say, in your organization you'll have a different departments, right? You'll have a human resource department, and you'll have a finance department, and you'll have a maybe the IT department which is also there. So when you talk about that, let's say you can, if you go and search for the details about your colleague, you can easily see them, but you will not be able to see the salary of that employee. So as a fellow colleague, suppose, let's say, if your colleague is working with you, if you want to know the salary of that employee, how much he is drawing, you'll not be able to do that because that's a confidential information, and that information is actually accessible only to the HR, your HR team, or to your finance team who can actually see that. So it is the same data table which it is there. Like, you have an employee table. In employee table itself, you have a last name, salary column, job ID, and all those things. You can see everything about the employee, but you should not see the salary, right? So when I query the table directly, select star from employees, what it says, it gives me even the salary also, but salary should not be visible to the IT, whenever you're actually querying that one. So what you can do is, you can create a view which will internally refer the data from same employee table, but it will not contain your salary column. So what we do is, we'll create a view here. Let's say if I am retrieving the details called as last name, and I have a job ID, I can see the job ID of this guy, and I can also see the department ID, so which department they belongs to, and the last name, job ID, let's say the email address. From, let's say you have an employees table, so I'm creating an employees table. So when I try and execute, basically it will create a view called as emp underscore Jan 2015. So now the view is created. So if you go and refresh here, I can see my view here, which it is present, employee underscore view, which it is there. So if you see this, okay, I think this is not our view. One second, let me just go to employee John 2015. I have a last name, job ID, and the email address. See, now I have created a view to the IT department employees. I'll give access on this view to view the data. Basically, I'll give access on this object to the IT employees. So whenever they query this view, basically they'll be able to see the last name, job ID, and email. Will they be able to see the salary of an employee? No. So in order to hide the data from different users, views will help you to do that. So how to retrieve the data from view? Just like a table. So you can write a query. So use select star from this. Now you're able to retrieve the data from same employee table, but you're not able to see the salary column. So this way, for a different, you can present a different views to the different users based on the privileges what they have. So likewise, the views will help you to hide the data from the different users. So let's say when you compare the definition here, is it a simple view or a complex view? So I need a response here. So what is the simple view definition? We said if it contains one table and it doesn't contain any function, and if it doesn't contain any group by clause, then that is called as a simple view. So do you have that kind of a clauses here? No. So that's why this view is called as a simple view. So if it does not contain anything. So what do you mean by a complex view? So suppose if it is reading the data from more than one table, or if it contains any function, or if it contains any group by statement or something, then that is called as a complex view. So when you start doing it, this is a complex view what you have. So simple view and the complex view. So often you will not come across the creation of different views in your general informatica end. So this is something, this is a simple view. Let's try to create a complex view. So complex view is like which is reading the data from multiple tables. So go here, create a view. Let's say EMP aggregated salary. I want to calculate the employee aggregated salary. So as, let's say, select, you have, I want to get the maximum and the minimum salary of each department. So how would I get it? So select from, let's say if I'm joining departments with the employees table, departments D, let's say inner join, I'm joining it using a inner join, employees table, let's say E. What is the join condition to this? D dot department ID is equal to E dot department ID. So I want to get this one, let's say department name, and I need to calculate the, let's say, average salary of it, average of E dot salary, comma average of, or let's say minimum of E dot salary, minimum of E dot salary, okay, and max of E dot salary. So this is, and I need to group the data. So is this query is correct? No, you have to group the data based on the department name. So group by department name. So is this a complex view or a simple view? So it is a complex view because it is reading the data from multiple tables and then doing it. So when you try to execute this, name must be used with an alias. Okay, let me just provide an alias here, average salary and the minimum of salary, let's say the maximum of salary column which you have. So try to aggregate it. So employee underscore Jan 2015, which it is there, and this is created. So this is just a complex view which we have created because it is referring to this one. Is the alias is mandatory in joins? No, it is not mandatory, but in a view you cannot refer this column without an alias. That is the reason we are providing an alias here. So it is not mandatory when you are using a joins, but it is mandatory when you are using expressions inside a view. So select star from employee aggregate this one. So this will give you the aggregated salary according to the each department. So this is called as a complex view. So not often you come across the views in the real time. It is just that conceptually you have to know when you are working in a data warehousing environment, you might not really use the views to do that, but in a reporting environment, you probably define a different types of views to retrieve the data. So it is conceptually you have to know what is a view is all about. So when we talk about a view, view is something logical and which is not physically stored. It is in fact, see, you need to understand here, whenever I execute this query, is this query is internally reading the data from employee table and department table, or do you have a separate storage unit? Which has the data here? I mean, it doesn't have a separate storage. It's basically reading the data from the existing tables only. It is just a container or a preview you can call. So it's a kind of a preview to read the data from that. So that is main thing that you have to understand here. So when you try to execute select star from this one, it is internally reading the data from your employee table and the department table. So when you talk about the materialized views, why I'm specifically telling whenever you're querying, it is internally firing this query to the database. So what happens whenever I query, since it is a view, it will go and look what is the query associated with this view, and that query will be executed in your database and the data will be returned back. So if it is a table, it will directly retrieve the data. If it is a view, data which is associated with it. Let's say if I want to know what is the maximum and average salary for an IT department, can I write something like this on a view where department name is equal to IT? Is this query is correct or wrong?
It's correct.
Okay, so when you try to execute, it's a correct query. So view is just like a table. You can query it, you can alter it, you can apply the aggregate functions, anything you can do it. So it is just like a table. So if I have to calculate, let's say I want to calculate the maximum salary or maximum average salary, so I can also write it. It's just like a table, you can perform the operations. But can I perform the DML operations on the view? Yes. In that case, if it is a simple view, you can perform the DML operation, which in turn updates your base table. If it is a complex view, you cannot perform the DML operations. But it is not a good practice to perform the DML operations on the views, but still Oracle allows you functionally. If it is a simple view, you can still perform the DML operation. When I say DML operation, it's nothing but insert, update, delete operations. You can still do on top of a simple views, but not on the complex views. Complex views, it doesn't allow you to do that. So just like a table, you can do whatever you want. But when it comes to the materialized views, is materialized views are logical in case of your database? No, absolutely not. Materialized view is something that physically exists in your database, just like your table physically exists in your database. So when you go back to the paint diagram, let's say this is your view wherein you're actually having employees table data and which is being retrieved here. So when you look at the materialized views, basically based on your query, your data will be separately stored. Suppose let's say if I'm calculating aggregated salary, all the data based on your query, entire data will be stored in a separate unit. It's a separate storage unit. The data will be stored. So whenever you change the base table, suppose let's say if the new record is added to the base table, or if the record is updated in the base table, or if the record is deleted in the base table, data will be automatically refreshed based on your definition. So suppose let's say I have created a materialized view with the same name. So assume that this is my materialized view. Basically we will use a materialized views for a complex queries, not like a simple queries, but I'm just using it as where materialized view as I think this you have to represent in this refresh on demand. So as select star from employees. I'll tell you what do you mean by refresh here. name is already used by an existing object. Okay, let's call it as this. Okay, now the materialized view is created. See, you have actually mentioned it as refresh on demand. See, this is a materialized view which you have created. If you go here, all the materialized views will appear over here. This is the place where you can see all the materialized views. So if you go and check, all these materialized views are also associated with the query, but it is physically stored separately. It will exist in the database. Now what happens, suppose let's say today if I have 100 records in my employee table, when I create a query, it will also store the same 100 record in the materialized view. Okay, so in future, let's say assume that I'm adding some 10 employees who have joined my organization. These 10 employees have been added to this employees table. So basically whenever this 10 employees is being added, the same 10 employees are not present here, right? So how the data will be replicated here? So you can refresh the data automatically. You can set property as refresh on auto. Means whenever a new record is being added to employees table, the same record will get added even to the materialized view also. In case if you say refresh on demand, what does that mean is you have to explicitly refresh it, which means it will actually synchronize the changes between your base table and the materialized view. So basically the materialized views are used to make your complex queries easy. So since it is a pre-aggregated data which is already available here, so materialized views will give you the better performance in case of a data warehouse. Basically in a data warehouse, wherever you have a complex queries which are involving around some 10 to 15 joins and which is being performed on some 100 million records, every time if you fire that query which contains a 15 joins and 100 million records, it probably take 2 hours of time to execute the query if you have a complex query. So in order to make that complex query easy, you can create a view as and when your base tables are get updated, your view also will get updated with that query. So which means it is like whenever I read the data from materialized view, I can just read it like a same view only. I mean just the way how you have seen the view to do that. So in this way you can also define a materialized view and retrieve the data from this. So main difference when you talk about what is the use, when you talk about a materialized view and the view is something which is a logical and materialized view is something that which is physically exist in your database. So this has to be refreshed or it will be automatically refreshed based on the property that you set. In a data warehousing industry, what are the general use cases? So generally if somebody asks you is that when did you use a materialized view? So you can tell them basically we were actually interacting with a remote database, or you can give the example. So every time when you go to the interviews, people will ask you what is the use case. Use case is nothing but a requirement when you have used a materialized view. You can explain them, let's say we had a query which was having some 15 joins with 15 tables. Each has some 10 million records. 10 million records with different aggregate functions, aggregate functions. So this query was taking a long time. Let's say this, you can mention it as this query was taking a long time, and so we have used a materialized view to make this query as a simple. So this is how you have to explain if somebody asks you what is the, in which scenario you have actually used a materialized view. So with a different aggregation function which was taking a long time, and when we have created a materialized view and we used to refresh the materialized view, explain them, used to refresh the materialized view through stored procedure. You can call like this, through stored procedure, which you can use it and define. So this is more about the this is more about the different type of view and then the materialized view that we use here. So any questions on the views and materialized views?
Yeah, I have a couple of questions, Karthik. First question is, if it is refresh on demand, what is the command you will use to refresh the materialized view? Just do a select on the materialized view, or
there are a predefined procedures in PLSQL. So something like dbms underscore mview. If you open that PLSQL API, you can just pass the materialized view name. It will automatically refresh. I mean, basically you have to invoke that procedure. So there are a lot of basic learners here. I'm not going in much details about it. So if you say that, there will be a lot of confusion, but that's the reason you have a predefined procedures which you can do it. When you say that refresh on demand, you invoke it from the procedure and schedule that procedure. So every time, let's say, if that data has to be refreshed, maybe every day at morning 8 a.m., it will refresh at morning 8 a.m. So the data will be available for you.
Okay. And is there any restriction on number of materialized views which we can create?
No, there is no.
Or something? Okay.
No, there is no restriction. You can make any complex query into the materialized view, and you can do that. Yeah, we have a question here. What do you mean by refresh on demand and refresh on auto? See, while creating a materialized view, you define it as saying refresh auto. That means if your query involves, let's say, some 5 tables, okay, as and when your 5 tables get updated, your materialized view also will get refreshed. If that is refresh auto, means you're asking Oracle to refresh it whenever there is a change in the data. That is called as a refresh on auto. When you say refresh on demand, what does that meaning is that explicitly you have to refresh the data, unless here when I say 10 records have been added, if you say that refresh on auto, whenever you add these 10 records will be replicated here. That means automatically it is taking care of the changes. When you say refresh on demand, you have to explicitly write a program to refresh the data. That's nothing but a procedure you have to write. That's what I was talking about. You have to write a procedure to refresh the data so that it will have this 110 records here instead of 100 records. So that is the use of your materialized views. And then this. Will there be a performance issues when you use a views? Basically, in order to avoid the performance issues, we are going for a views. If you still have a performance issues with a view, then there is no meaning of defining a view. So most of the scenarios we are going to avoid the performance issues. So when I say this example, it is absolutely based on the performance only. We are going for a materialized view. So when you say again it is having an issue with the performance, then it's better to read the data from this. I don't understand your question, Kranti, here. How use case is related much in materialized views? I don't know. When I say use case is nothing but a requirement. Don't try to treat this use case as something as a concept here. So use case is like a requirement. So when somebody asks you what is a use case that you have used or what is a requirement that you have used your materialized view, that's what I told you this one too. Okay, in real time, where do you use a views? I gave you an example. A view is basically in your organization. As a colleague, you can see the details of who is working with you, but you'll not be able to see the salaries, right? So that is one example where you can hide the data from the different users. So if your colleague is knowing about your details, he'll be able to know all your email address, phone number, everything, but they'll not be able to see the salary. That means you're actually projecting a different view to that user. But when the HR user retrieves the details, they can see your salary and all the confidential information as well. So that is one thing in case of a OLTP. In case of a OLAP, views we don't use much, but it will be used for a reporting. So when you go for maybe when you go to the data warehouse, you'll understand more about it. The why, I mean, where what is reporting and all that that you'll understand more here. All right.
Karthik, actually on this requirement, how does materialized view, I mean what we are trying to achieve using materialized view?
Okay, what did you understand about materialized view so far?
So actually it is used to make complex queries easier.
Okay, so what is this about? Now, when I say this one, what did you understand from this statement?
This is a complex query.
It's a complex query. So for that, you're creating a materialized view, right? So whenever I fire my complex query to database, if it is taking 2 hours of time, my complex query result I'm storing as a materialized view. I'm storing the result of the complex query in my materialized view. Okay. So suppose let's say you have 10 tables. Basically explaining the real-time scenario would be little difficult here. Okay, let me just try to quote it. So suppose all these 15 tables with the 10 million records are calculating the aggregated salaries. Just in a simple case, you just understand. So you are calculating aggregated salaries for each department. Okay. So you have a department name, you have a maximum salary, you have a minimum salary, and you have the let's say total salary and then the average salary. So these are all the aggregate functions which my query is using. Okay. So when I'm firing this query every day, because of the data what is present in these tables, this query is taking a long amount of time to calculate all these values. Okay. So far you're with me? Okay. Then
yeah,
when I am creating a materialized view, which means the data what is written by the query will be stored here. Let's say if your IT department and 6,000, let's say minimum salary is 4,000 and the total salary is 10,000, average salary is 5,000. Likewise, you have a multiple records here. Okay. So whatever the data, I mean whatever the result that you are looking for with this complex query, that data, pre-aggregated data is already being stored here. See, whenever if you want to know what is the maximum salary of this, then I can directly query the data from materialized view. I don't need to use my query, right? Because my query result is already stored in the materialized view. So whenever I'm accessing that aggregated data, I'll go and retrieve the data from materialized view. I don't need to go for my query and then execute it again, which is taking 2 hours of time to retrieve for me. So when I go and query this data from the materialized view, it hardly gives me in half a second. You don't need to wait for 2 hours to retrieve the result, which means whatever the complex query result that you wanted to retrieve every day, I'm already aggregating it before I hit that table or before I hit that view. So that is the reason we are storing. So it is physically storing whatever the data that you require from that complex query in the form of a table. You can call it as a table itself. It's just like a table format. It will store and then retrieves it. So you don't need to execute your complex query every time. That job is done by your materialized view in the backend.
okay, got it.
So that is the main use. When you say that, then the changes will not be up to date. So when you talk about the changes will not be up to date, that is where your definition comes into picture. So you need to think about this clause when you say that. When you say that whether it is refresh on demand or refresh on auto or refresh auto. So when you say refresh auto, whenever these 15 tables are updated, your materialized view also will get updated accordingly. Suppose I have introduced a new employee to it. Let's say that employee is earning a 10,000 salary. What will happen to your sum of the salary? It should become 20,000, right? 10,000 is a new salary. So it will get updated automatically. When you say refresh on demand, that is your duty. So when the changes are not happening, that's your duty to change it explicitly before you retrieve the data from the materialized view. That's how it happens.
Yeah, yeah, and just to add Karthik's answer, I'll tell you a real-time example where we created a dashboard, in other words, a graph for one of the client, and we were using the similar view concept. Then we found that the number of tables we are joining and the number of records it is pulling is taking practically 5 to 6 minutes of time to load the graph. So for that, we created a materialized view where it stores the data in it physically stores in some other location instead of a table. The retrieval of the data itself happened within less than half a minute. Okay, so that is the one of the main advantages of materialized view, because it stores the data in a different physical location. That's why you can able to retrieve the data much faster.
Okay, everybody is clear or still? Okay, so would it be same time to execute the query if it is auto? I don't think, I mean that still you're actually understanding it in a different way. So when you say that refresh auto, it is not that when you're executing the query it is refreshing the data. The data is already being refreshed for you. You don't. So it is not refreshing the data when you're executing the query from the, or when you're retrieving the data from the materialized view. Data is already there in it. So that is what you are doing. That is the advantage of the materialized views. All right. So thanks, Praveen. Yeah. Yes. Yeah.
In real time, we'll be having the access to create the materialized view, or
see, you're actually working in as a developer.
Admin team?
You're working in as a developer. It depends from project to project and the client to client. Most of the cases you will have an access to the create the materialized views and all. We'll basically create the views or whatever in the development environment, and that is what yesterday when we talked about the script, these scripts you'll pass it to the DBA to create in the higher environments. So you create in the dev and pass it to the DBA, they will create in the UAT or your production environment, so that the same way your program will function in the same way. So that is called as a script preparation. So when you talk about creation of tables, creation of views, creation of materialized views, or creation of procedures, or creation of packages, all these things as a developer you do it in the development environment, and you'll move those changes to the UAT environment or the production environment. Auto refresh is better than on demand. It depends. Again, let's say auto refresh, if you keep it as an auto refresh, you don't have to do anything. Entire Oracle database will take care for you. You don't need to do. So if you do it on demand, then it's a job of, it is your job that data has to be refreshed before you read from there. So that is another way you can do it. So that's more about the materialized views. Okay, thanks for your inputs. Okay, let's move on with the next one, that is about the indexes. So most of you might have heard about the term indexes. Why do you need an index, and where do you create indexes in a database? So basically, okay, so why anyone will use on demand then? So see, if it is a database, basically, okay, before stepping into index, we have another question here. Why do we use on demand in that case if the refresh is better than on demand? Okay, so case is that, suppose let's say I have those 15 tables, and those 15 tables are getting updated very frequently. Assume that if the tables are being frequently updated, what happens? Every time you update the table in the back end, it will keep on firing the implicit action, so which might slow down your insert update operations. Okay, so if there is a dependent object, unless that dependent object is updated, your insert operation will not be succeeded. So in those scenarios, instead of taking the overhead of waiting for it to update the materialized view, maybe in the off business hours, I don't want to disrupt that, I don't want to slow down my database performance during the business hours. If I'm doing it in the business hours, it will basically impact my business transactions and all those things. In those cases, basically to avoid such kind of issues, what we do is we refresh the materialized views in the off business hours. When you say off business hours, maybe in the midnight, sometime like that, we refresh them and we keep it ready for a tomorrow's refresh. So that is the reason your data warehousing loads and everything will run in the midnight. I mean to say the off the business hours, it will run not in the day level, because daytime your business users will be accessing those reports, or business users will be accessing that application. So that should not impact your business users' performance again. So that is the reason refresh on demand should be used. Most of the time it should be used, and it has to be refreshed only in the midnight. So that's easy.
Yeah, and to add to that, while doing the creation of materialized view, one can actually define the time and number of slot. I mean timing, like in how many seconds or how many minutes you can, if you want to refresh, you can define that. For every 1 hour, you can, if you want to do a refresh, you can define that while creation of the materialized view. As Karthik don't want to go in depth on that, so I didn't jump in and was not mentioning about this. Okay. Thank you.
No, sure, thank you. So the next one, which we are talking about, the indexes. So what do you mean by an index here? Let's say whenever you are writing, we are talking about so many things, so much on the complex queries and all. So whenever I'm firing a query to the database, it is taking certain amount of time to retrieve the data for me. All right. So basically, if you are defining the indexes on the columns which are used in the where clause of the query. So if you are defining the indexes on those columns, basically it will improve your performance and the data will be retrieved faster than the normal without the index case. So indexes are defined on the columns to improve the performance for the data retrieval. So what is the use of index? It's only the use of index is to it makes the retrieval of the data very easy, or not easy, or you can call it as retrieval of the data will happen in less time compared to the general query process. So there are the different types of indexes. Our indexes are basically classified into two ways in one sense. So one is called as a unique index and another is called as a non-unique index. When you say unique index, it maintains the unique values in the column, just like your maintains the unique values in a column. So just like your primary key and the unique key. So by default, your Oracle creates a unique index whenever you enable a constraint. Primary key by default, Oracle creates the unique index when you enable primary key or a unique key. Primary key or a unique key. So this is unique index, and non-unique index is nothing but which will maintain even the duplicate values as well. So there are the other ways of classifying your indexes. So that is called as a bitmap index, B-tree index, and you have a function-based indexes. Function-based indexes. So these are all the different indexes that we have in Oracle. So basically, a bitmap index is created on the low cardinality columns. So what do you mean by low cardinality? Low cardinality columns, and let's say if you say that is a low cardinality, the number of distinct values on a column should be less. That is called as a low cardinality. Let's say you take an example called as I have in my employee table, I have something called as a gender column. So the possible values for this is M and F. So when you see this, what is the cardinality of this? It's only the two values which are present. Let's say you have another column called as a country column. So my business is actually spreaded across the 5 regions or 5 countries. Let's say USA, India, and you have Australia, and then the New Zealand. So let's say these are all my countries. So what is the cardinality? It's nothing but 4 distinct values which you have. So whenever you have such type of a columns, then we enable a bitmap index on those columns. So what is a B-tree index? B-tree index is actually preferred for a columns which has a range of values. Basically for a salary column, or you have a revenue column, let's say if you want to find out. So range of values, it's a kind of a tree structure. Okay, function based indexes, it's basically created on columns like last name column or a employee name, product name, all these kind of columns we create a function based indexes. So for a time being, what you remember is, remember that you have only the indexes we are creating only to improve the performance. So how do you create an index on a column? Let's say, see, one thing that you have to remember is that index should be created, it should be created on the columns which are used in the where clause, Basically filtering the data becomes easy when you are using an index. Let's go for creation of these indexes. Let's say if I have to go for this, when you go again, let's say I have to create an index on the student column what we have, student table what we are here. Let's say if I have to do that, create index. Let's say I want to create basically I'm using the student name column more in my where clause of the statement. So I want to create an index on the name column. So if you want to see the list of indexes, you can go and see here. I have only one index, that is on the SSN number, and there is another index which is created on the primary key, I think, student ID. So these are the 2 unique indexes which are created because I have a primary key and the unique key on the table. So when you go here, let's say I want to create on the name column, I can create something like this, create IDX name, let's say student of, let's say what is a column name, it's going to be the name column. So create index name table of, and this create index on, I think, yes, it's on, keyword should be there, on table this. So try to execute. Now the index is created. So go and check here. So you have another additional index which has been added, and this is more about the creating a general index. If you are not specifying anything, that becomes a general index. Let's say if I have to enable the function based index. Function based index means either you are storing the value according to the function in the index. So okay, let's say, let me drop this index and recreate it. I'll show you how to create the function based indexes. So basically, and student of upper of. So when you try to execute, now this is created. So when I say upper of name, that means when it is storing the values for a name column in the index, it will store all the names in the uppercase. So since you are using a function while defining an index, this is called as a function based index. So if you go and check, so this is function based normal index, see here. So these are all the general type of an index, and this is like a function based normal index. So likewise you can define different types of indexes in using that. So creation of more indexes is also not good. What happens if you are creating more number of indexes on the table? What is the disadvantage? See, it is good that if you are creating a table, retrieval of the data is easy. But if you are creating more indexes on the table will makes your DML operations slow. More indexes on this table makes your DML operations slow. What are all the DML operations? When you talk about insert, update, delete, these operations will be slow. That is the reason when we are inserting a data, we always drop the indexes, and when we are creating the indexes, we recreate, when we are loading the data, we drop the indexes, and after loading the data, we create the indexes. Because so loading, I don't want to waste my time. That is the reason I'm dropping all the indexes, load the data, recreate the indexes, then retrieval of the data will be faster. So in your OLTP tables, anyway, we'll talk about what is OLTP. Okay, for now, you remember in your OLTP applications, the indexes will not be created more. Basically, those are all for handling the transactions. Handling a transaction means adding the data to the OLTP systems. So basically, the OLTPs, we don't create more indexes, but in OLAP, we create a more indexes for the data retrieval faster. So that is more about the indexes, how you use the indexes in this case. All right. So bitmap, B-tree index, and remaining all the other things are similar. You can probably explore more about it. And can we drop a view? Yes. So what is the procedure to drop a view? It's drop view and then the view name. Let's say if I want to drop this view, I can just give this condition, drop a view. We didn't talk about it. That's the reason you can drop a view with a simple thing. So similarly, you can also drop the index. I think we have seen it, how to drop the index as well. You can provide the name of the index, so that will drop. So these are all the DDL statements or the DML statements. Your create, alter, drop, truncate, these are all the DDL statements. So data definition language statements. All right. So that way we are concluding the indexes, how the indexes are being used, how the indexes are useful. All right. So next one is about the sequences. So sequence is a database objects. It's a database object which produces the unique numbers, or you can call it as a unique integers from the minimum value to the maximum value. So basically sequences are used to populate the values into your primary key column or to populate the values into your unique key column. Whenever you want to populate, you'll make use of the sequence. So basically, if I have to add a student ID column, see, if I have to add the data to student ID column, every time I have to first identify whether that record is already present. If it is not present, then only I can add it. See, in the real time it is not possible, right? So you can go and check each and every record whether 100 student is there, 101 student is there or not. It's basically we cannot verify each and every record and add it. So we need to have certain object which gives me the unique numbers. So whenever I'm adding a data to that column, student ID column, which is a primary key, so I'll make use of that sequence and keep on adding the data. So basically the sequence will help you to produce the unique numbers. So how do you define a sequence? When you go here, let's say create sequence, let's say you have this thing as sequence underscore. Let's say I have student ID. I don't think I have a sequence called as a student ID. Let me check here in this. I'm checking that sequences here. All the sequences will appear over here. So yeah, I have already something called as a student ID sequence. Anyway, I'm creating that with a different name here. Sequence underscore student ID. You can define, while defining it, you can mention from which value it has to start with. So you can mention it as start with 1, and you can increment the value. Let's say if you increment by 5, it will generate the values as 1, 6, 11, 16, 21, 26, like that. So if you increment by 1, it will generate 1, 2, 3, 4, 5, like that. So you can start from any value, and let's say increment by 100. So it will generate the values as 100, 200, 300, 400, and all. And this is how you can define, and you can also provide the maximum value. So maximum value can be generated by this sequence is this. I can provide something like this. Beyond that, it will not generate. So once it reaches the maximum number, it will throw the error saying that you have already reached the maximum number, you cannot proceed further. So that is a use. So if I have to define, so just sequence is created. Sequence uses the two pseudo columns. One is called as a next val and other is called as a cur val. So one will give you the next value of the sequence and cur val will give you the current value of the sequence. Next value of sequence, and this one will give you the current value of the sequence. Current value of sequence. This way it will store it. Next value of the sequence and the current value of the sequence. So let's say whenever I want to find out the next value, I can use like this. So select, let's say sequence dot next val from dual. So try to execute. This is giving you next val. So if I use one more time, it will give me 200. So what is the current value of sequence? 200. So that's the current value of the sequence. If you try to see this, select sequence underscore student ID dot current value from dual. So when you try to execute, so this will give you the current value. So basically whenever you are adding a data to the table, right, you'll always make use of, whenever you want to add the record in the insert statement, you'll mention it as student ID underscore sequence dot next val. It will always bring up the next value from the sequence and generate it. So that is the use of the sequence, how you use the sequence. You can also drop the sequence. So basically if you just want to drop it, yes, you can use it anywhere. It is not only for a student table. If you want to use even for other tables also, you can use it. Basically, let me just show you the example here to add a record. Let's say I want to add to student table. This student table, where did I add it? In the SQL, I have the student, right? Okay, let me go here. Give me a moment. And I have a student table here, right? And it has a student ID, student name, and the course. So let me add student values. So I can use here directly sequence student ID dot next val. It's basically I'm inserting into student ID, comma, what are all the columns that you have? Student name and the course, right? Student name and the course that you have. what are the values? So student ID I want to generate from this, so use this value as a next value, so it will always pick up the next value from it. Let's say name, you have it as Rajendra, and let's say course is IPC, Informatica Power Center. Right, when you go and then see here, let's say, so try to execute this, row is added into this. So when you say row is added, so go and verify whether this record is being added. See, this is 2100, and then this is the value this being added. So this is how you can use the sequence while using a insert statement. So that is more about the sequences. So if you want to drop a sequence, so it's a pretty simple thing. Drop sequence, and you have this as a sequence name. So try and execute. Sequence is dropped. So that's how you manage the different sequences in this. Yes. Do we have to mention that a sequence statement every time we insert a record? Yes, you have to mention it. Otherwise, it cannot understand from which sequence it can populate the data. All right. So this is more about the sequences. Next thing is about the synonyms. So synonyms, or you can call it as an alternative name provided to an object. Alternative name provided for a object. Alternative name provided for an object. So when you take a look at this one, basically we need to understand about what is a database, what are the schemas, what is a user that you have to understand the. Let's say you have an ORCL database. ORCL is a database. Under one database, how many users we can have? Many number of users, right? So let's say I have some Scott, HR, let's say SQL1, like this. You have the different. So these are all the, let's say this is your HR schema, and this is your Scott schema. So you have different schemas, and this is your let's say SQL1 schema. There is another user called as an SQL1. So if you are creating a table inside SQL1, let's say called as, I'm creating a table called as a student. So this table is already available, and I already have the another table called as a student underscore address and all. So you have a different, so you have different tables, and even in this HR schema also you have a different tables like employees. So I need your response here, okay, employees, and let's say I have a departments. So both are available in the same database. Can I access this student table from this schema, HR schema? This student and student address are owned by the SQL1 user. But can I access this student table from this? Provided if you do not have a privilege. If you do not have a privilege, definitely you cannot do that. So assume that there is another type of a language that we understand that is called as a DCL, data control language. What are all the different commands that are part of your DCL? Grant and the revoke. Grant and revoke are the two things. One is grant is used to give the permissions on an object. Revoke is used to take the permissions from the object. Let's say, assume that if the SQL1 user has given a grant, has given a privilege, basically has given a insert, update, delete privilege on this student object, grant, let's say basically select, comma insert, comma update, comma delete. So all the kind of privileges this user is providing to you. So let me just try to represent it here instead of doing that. I'm just showing you the theoretically how it happens. Okay. On what table you're giving a privilege? Student. To which user? To HR user. So this is a statement. So assume that you are providing a privilege to the HR user. So can this user now access the table from the HR schema? Yes. So if there is a privilege provided by the SQL1 user to the HR schema, they can access it. How do they access it? See, whenever you are accessing the other schema object, okay, whenever you are accessing the other schema object, always you have to prefix the schema name and access it. Let's say if I am accessing the object from the SQL1 user, so I need to write a condition like this: select star from SQL1 dot student table. So what is a SQL1 here? It is the owner of this object. SQL1 is a schema name where this object is available. So whenever you want to access any object from the other schema, you need to prefix the schema name. So how do I access student address here? Select star from SQL1 dot student address. So that is how you can access. So now basically you are prefixing the schema name and accessing the object. So can I avoid or can I access that without prefixing the schema name? Can I access without prefixing the schema name? Yes, there is an alternative which we can provide, that is by using a synonym. So what we can do is, instead of prefixing the schema name whenever you are accessing, you can create a synonym for it. So how do I create? Let's say create synonym. Synonyms are of two types. One is a private synonym, another is a public synonym. So if you're not mentioning the public keyword, that becomes a private. If you're mentioning the public keyword, that becomes a public. So create synonym, let's say std for, let's say if you want to create SQL1 dot student. Now this student from the SQL1 schema can be accessed using this. And if you'd like to drop the schema, drop the synonym, you can use it. So drop synonym, and then this is a statement. So basically the synonyms helps you to provide the alternative name to this one. So if I am creating a synonym in HR schema, let's say I have created a synonym in HR schema, a student std is a private synonym, which I am creating it in the HR schema. So whenever I retrieve the data, it is basically reading the data from student table in the SQL1 schema. So when I'm reading the data, so if the HR user is only creating this one, this is like a private synonym. Only HR user can access. Other users like Scott and all, they cannot access, because that is a private synonym for that user only. It is not a public synonym. Everybody cannot access it. When you say it is a public, if you are creating a public synonym, that can be accessed by anyone within the database. So if you have a user called as Rajendra, or if you have a user called as Mahesh, anybody can access within the database if it is a public. If it is a private, the user who has created that synonym only can access. That is the use of your synonyms. So synonyms are just an alternative names provided within the database. Now here you have to concentrate. Okay, let's say these are two are within the same database. So with the help of synonyms we are able to access, or with the help of prefixing the schema name we are able to access the object. Let's say I have another database called as a EDW. Under this I have a schema called as a EDW stage. Assume that there is a schema called as a EDW stage. If I want to access the object which is existing in the SQL1 schema, can I access from here? I need your response here. So my question is, I have a table which is present in this database, and both are Oracle databases. Assume this is an Oracle database and this is an Oracle database, and I want to access the student table from my EDW stage schema. Can I access that?
Yes, you can. You need to create the database link.
Yes. See here, if you have to access the other database objects, then that can be achieved by using a database link. And the database link can be established only between the two Oracle databases. So when you say here, I'm creating a database link, so I have to create a database link. Generally it will be done by the DBAs. So create EDW to ORCL. This is my database link. Database link can exist between only two homogeneous databases. Suppose this is Oracle database and this is SQL server. I cannot create a database link. Database link can be created in this. So when you go here, let's say I have created a database link, and if I have to access this table now, how would I access? With the database link, let's say database link name is EDW underscore ORCL. How to create it, you can actually explore it. It's done by the DBAs, and you can also do it if you have a privilege. So if you have to access the student table from there, you can write it as SQL1 dot student @EDW underscore ORCL. So this is the way that you refer an object from the other database. So this is your whatever you are using, that is a database link name. So it basically, whenever you execute it using this link, it will execute the query within the database and retrieve the result back to you. So that is called as a database link. Database link will help you to do that. So that's more on the database link and the synonyms. Okay, let me answer the questions in case if you have any here quickly, please. So database links often you come across in the real-time environment, because we deal with most of the different databases, multiple databases. In order to create a synonym in HR, should be the grant given to HR on the student table? No, you can create a synonym, but basically when you execute it, it will throw the error saying that you cannot access that object. So you can create a synonym. If there is a privilege, then only you can access it. If there is no privilege, it will throw the error saying that table or view does not exist. That is the issue. But for creating a synonym, definitely without a privilege also you can create it, but it won't work. That is a case. That's it. So that is more on the database objects, different type of database objects what we have. And I missed to add one more thing here, that is about the partition. Like partition is very, very important in the data warehousing environment. You need to know different types of partitions that you can create on the table level. Basically, let me just pick up a good document from here. So you have to know all these different partitions and what are the different concepts that you have in the partition. So this is a good site where you can go and refer oraclebase.com. So you'll have a good information here, and which is a straightforward one. So basically the maintenance of the large tables and the indexes will become very easy when you are actually dealing with a high volume of data. So it increases the performance, and partition makes a backup and recovery operations very easily, and you can actually it will increases the parallelism by reading the data from the more partitions. So partition, if I give you a correct example how the data is stored, forget about what kind of partition it is. Okay, so let's say if I have a table, instead of storing the table, instead of storing the data in a random order, basically I'm storing the data in the organized manner. So basically, let's say you have a data which you're storing in a table according to the each country. If I have a column called as a country and which holds the values like USA, India and Europe, and let's say something like this, you have a different values. So I'm inserting a data into this table. Basically, when I'm adding the data, I want this data to be organized in a proper manner. So when you create a partition on a country column, this is called as a list partition anyway. So when you create a partition on this, it will basically divide your yeah, I think you can keep yourself on the mute, please. Basically you can divide the data into different partitions. Let's say whenever you add any record which belongs to India, it will be added here. Whenever you add any record which is there, you'll use USA, and whenever you say the record which is added here, EU, likewise it will actually organize your data in a proper manner. So when you say that what is the need of storing this data like this, basically when you do it, retrieval of the data is very easy. So let's say when you're writing a query, select star from customers where the country equal to USA. It is need not to look entire database, right? So it just have to go and pick the data from your USA region. It is need not to look for your India or the Europe or wherever it is this. So this is more on the database partition level. It basically organizes the data into different partitions. So when you talk about the data that is being stored, what are the different partitions that you can create? You can basically create a range partition, list partition, and you can create a hash key partition, and you can create a composite. Composite is nothing but a it's kind of a range plus list partition or range plus hash. So likewise, composite partition, all those different types of partitions you can create. So you can explore more on this. I'm not actually going in much details about how you go with it. Maybe you can find out a better document and then go through it. It's just that conceptually you have to know this, because creating a partitions is often required in a data warehousing environment for a faster data retrieval and for a faster maintenance. You need this to be done. Probably we'll look for a document and then I'll send you that, and in that way you can just know about what is a partition and how it can be enabled on the partition. Basically you also need to know how to create a partition. See, so in the yesterday's class we talked about only how to create a table, but we didn't talk about how to create a table with partition, right? So I'll send you some sample examples how to create a table with partition, whether it is a range partition or an interval partition or all those. So but for now you can just remember what is a partition and what is the benefit of keeping the partition on a table. So in data warehouse every fact table will be partitioned. So you need to know what you mean by the partitioning of the data. This is in the terminology of Oracle that we are talking about. So it might vary from one database to the other database, the concept what we are learning here. All right. So that's pretty much about your today's class. In case if you have any questions quickly, let's finish it up in the next 5 minutes. And tomorrow we'll talk about the data dictionary, like how the data is stored, and then we'll go to the PLSQL. All right.
Karthik, I don't see any assignments in the SQL materials you have sent me.
You probably have to scroll down the PDF what I have sent you. In that you'll find it.
Okay.
So I have already sent you one Oracle 11G SQL fundamentals, and in that SQL fundamentals only you'll come to know. Yeah, save point, probably we'll discuss that in the PLSQL. What do you mean by save point? Probably you can remind me, we'll see that. What do you mean by RR date format? Yeah. Yes, it's important. When you say RR date format, basically this RR date format is used when you are dealing with the previous century dates. See, current century date, I mean current century is 21st century, and if you are referring the dates in 20th century, which is before 2000, then you need to use the RR format. So basically I think for one of the example we have to write it. I don't know whether I have that here to show you quickly. When I go to this, I think we have a ODS time. Okay, I think I have the data. Let me show you what is the use of RR format. So select star from, let's say, ODS underscore time. In this, I don't know. Oh, okay, I have a date ID which is a 99. So 99 means whether it is 2099 or 1999, how it understands. So this, if you have to, let's say I want to retrieve all the records which are less than 12/4/1999, December 4 1999. I think we don't have that. Okay, maybe greater than that, December 4 1999. So where, if you see where date ID is greater than, so to date of, let's say, DDMON 12 December 99, and you need to use here as DD-MON-RR format. So basically when you try to execute, it should return the result. See, it's basically retrieving me the data which is greater than 12/4/1999. So that's how the RR format. If you use YY format, it basically don't work because you don't have any record which is greater than 2099. So RR format should be used for a previous century dates. So that is the use of RR format. Okay, write a query that displays the employee number and last name of employees who work in a department with you, any employee whose last name contains you. You probably have to use not in operator here, Ali. I think you have to use in operator, not the equal to operator. So this query becomes this is basically a subquery which you have written returns more than one row, right? When you say this, when you execute this query, it returns more than one row. You cannot use equal to operator there. Table or view does not exist. Okay. Let me go on to execute the, maybe here. So there you have to use in, not any operator. So let's say if you try to execute, this will give you the, okay, it is giving only one, then probably, yes, it's fine. I think this is a way who are actually, okay, let me just read out the query again. Write a query that displays the employee number, last name of the all employees who work in a department with, with any employee whose last name contains a U. No, this is, I think question is still missing something in this. Contains A and U both. Okay, work in a department with any employee. Okay, you just ping me the page number here, which question that you are referring. Probably you can mail me that, I'll see. Okay, so trim of column name and L trim and R trim of the column name both are same. Yes, both are same. Ali, you can just mail me the number, page number in which this query is there, and we'll see that and send you. I'll reply back to you.
Karthik, do we use views, indexes in Informatica, sequences and everything?
Yes, we do use. Sequence probably we don't use, but indexes and everything we use. We have to, you need to know as a Informatica developer.
Okay, thank you.
Okay, thank you then. So that's it I have for the day. I'm closing.